Hi, my name is Brett Slatkin. I'm a software engineer at Google. I'm here today to tell you the secret to safe continuous deployment. These are some of my identifiers. You can find me online. Here's the agenda. So I don't have that much time. I'm going to try to cover as much ground as I can. I'm going to tell you my background. I'm going to tell you why and how you should be doing this. I'm going to talk about the mistakes that we've made and how we became safe. I'm going to give you examples of why this is useful, and then I'm going to talk about how you can use Pdiff yourself. So my background is I've been at Google for almost 8 years, which makes me a dinosaur, which is funny. But I started off in cluster management, reinstallation of machines, like the very bottom of the stack. Did security infrastructure, crypto, that kind of stuff. Then I worked on App Engine, and I carried the pager for App Engine for a few years. Worked on PubSub, real-time feeds, also carried the pager for that. And now I'm working on Google Surveys, also carrying the pager for that. So whenever you launch something at Google, you kind of have to carry the pager. So I'm a software engineer, but I've done a lot of DevOps, site reliability work in my time. I'm working up the stack. Eventually, I'm going to be in sales at this rate. Yeah. So why and how? So when I was working on App Engine, this was the typical release process that we had. 20-day release cycle. Once you commit your code, I'd be really excited, and I would commit my code, and I would branch it into some kind of staging cut release, and then it would get onto the staging server, and I'd be like, this is awesome, it's going to be so great. And then like a month later, it would finally ship. And my happiness and motivation, that's the green line here, it just totally plummeted during that time. And I noticed that really just killed my motivation and my effort. So it's like, work real hard so you can wait 2 weeks for it to go live. Now, meanwhile, I was working on PubSub, and it's open source, and we were using App Engine to deploy, and so we would push like every 2 days. And I realized that pushing often made me way happier. I was just way happier doing that. So it was seeing my code live that made me happy. And so this all makes sense, actually, because what attracted me to App Engine in the first place was deployment. So Ian Bicking from Mozilla, if you know him in the JavaScript or Python community, he said, when it comes to deployment, App Engine is the first thing that has really felt good to me. And that's right. It really is great if you've used it before. So you've probably seen this article if you've ever heard of continuous deployment. If you haven't read this, you should read this. It's required reading. This is Timothy Fitz on doing the impossible 50 times a day, which at IMVU, this is like when I first saw this, I was like, we need to do continuous deployment. I think this is from 2009. But when I read this, deploying to all their different servers, I realized it's almost identical to what App Engine does under the covers when you run app.cfg. It's the same idea. So then we're building this new product, Google Surveys. That's what I work on. We pick the rest of the stack as software developers. We're very deliberate about the tools that we use, so Django and Python and Clojure and JavaScript and HTML5 and all this great stuff. But we don't really talk about the process that we use as developers as much as we should for releasing the software. We talk a lot about the tools and the frameworks, but not the way that we actually ship the software. So I wanted that to change. So starting a new project, we said we're going to do continuous deployment as part of this team. That's going to be the thing that we're going to adopt. And so here's how it worked. The person who writes a new feature, in terms of they write the code, they have someone review that code. They check it into revision control. That does some kind of continuous integration process that then runs automated tests. Then we automatically kick off a deployment to a staging server somewhere. Then either the same person who wrote the code or someone else later basically does a quick QA cycle on the staging release and says, yes, it looks good, or it doesn't look good. And then you set it to live. You push it live. This is the kind of the typical continuous deployment case that you see. So we set this up, and we've been doing it for, I think, almost 18 months now, which is crazy. And this is kind of our peak of 40 deploys within a 24-hour period. So you write code, you submit it into our source code repository, and within between 5 and 15 minutes, depending on what's going on, it'll be live on a staging version with production data for you to poke at. So it's great. It's really great. And then once it goes on the staging version, this is the time that a version is live in production before it gets taken out. So on the weekdays, it's like each build that we push spends less than 24 hours in production. On the weekends, it's 3 days because we're not working, right? So this is like success. These are all great success metrics, I think, for continuous deployment. Been very happy pushing out code fast. The time from when I write the feature to when it's live is low. That's why continuous deployment is great for me as a developer, right? That's what I wanted. Okay, so I got what I wanted, right, which is pushing to production very quickly. Yeah, it was great, but then I did this. I pushed a dancing pony to production for all of our paying customers for days. So the story here is, it's a Django pony, Python Django. This was live for at least 24 hours, and the story goes that I was trying to learn CSS3 transitions, and it was a Friday, and we always refer to features as a pony, like, oh, I want a pony. And so I was like, I will mark all new features that we put an experimental CSS tag. I will mark all new features with a dancing pony. It'll be amazing. And so, I showed up at work, and I wrote the code, and we shipped it that day. But I didn't realize that it was turned on for everybody. I thought this was only for, I put it on the wrong div, basically. I put the tag on the wrong div. So anyway, the thing that was funny to me about it was that nobody noticed, nobody complained. Like, none of our customers were like, well, of course a pony shouldn't be there, So it says something about our product, but anyway, that's out of the scope of this talk. We had a lot of tests. We have continuous integration. There's a really great talk that I'll link to later about how testing infrastructure at Google works that I really suggest that you check out. We have a mountain of tests. They run on every single change, all kinds of metrics around it, and none of our tests pick this up. We have tons of graphs. These are real graphs from our system. I took the axes off. They don't make any sense with the axes either, so don't worry about it. But we know about error rates and all that kind of stuff, back-end lookups per second and cache hit rates and all that stuff. But I have no metrics of, does my website make sense to the customer right now? Even a JavaScript error, it would be helpful. But in this case, I have no end-to-end test that makes sure that the site is working correctly, right? So that realization that your tests don't mean anything, actually, your monitoring doesn't really mean anything, that sucks. So here are the things we tried and failed: monitoring, testing automation, continuous integration, manual code review. Someone reviewed the pony change and approved it. I didn't just sneak it out there, right? We deployed it to staging. So I looked at it in the staging server, and I'm like, yes, a pony, that should be there, of course. That was the intended goal of the whole thing. And then, we also tried a QA checklist, but the matrix there gets just so large so quickly, it was impossible. But the main thing is the QA checklist doesn't say, check to make sure that ponies are not showing on pages where ponies could be expected. It doesn't, there's just no way. Unknown, right? Okay, so let's talk about being safe. Since we learned from our mistakes here, we needed something better. And this is because continuous deployment is great and all, but if you keep shipping horrible features to your users, something bad is going to happen. So this is what we came up with. This is called a perceptual diff. It's a visual diff. And the story behind this is that it came out of Google for map tiles. They wanted to render new map tiles and change their algorithms and make sure that the map tiles looked about the same over time. And they hooked up some infrastructure that lets you do this for a web page. So this demo here, on the left and the right, are the same page on two different releases. And the difference is next to the globe under the little price tag, there's one number that changes, and that's it. It's almost impossible to see. But a computer can totally see this and pick it out and show you that this has changed. So it can pick up subtlety extremely well, regressions that you never expected, and most importantly, it can see what your customers would see, when they come to the site. So that's what the idea here is. We're diffing releases perceptually. Here's another more kind of clear example. This is our reporting page on the left. There's a histogram in the bottom left there that's how long it took for a respondent to take a survey. On the top is the expected histogram of response time. The one below that, there was a regression in the way we're using the charting library where the x-axis got blurred. Do you see that? And the Pdiff picked that up totally. But if you're looking at this page and breezing through it, you just never would see that. There's just no way that you would realize that there was a regression there. So that regression would be in production for much longer before you realize it happens. In this case, we detected it before the version was set live. So now we can continuously deploy to staging. We can check to see if we've regressed in any way that wasn't anticipated. And then, if not, we feel like we can push, set it live. Okay, so perceptual diffs, again, we screenshot the old release that's live in production. I'll talk about that a little bit more. We screenshot the new release. We pair them by the URL path so they can be on different hosts. So you can test your local one versus the production one. Then we visually diff the pixels. And that's that. So we first did this for a couple of refactorings. We were doing a big UI refactoring on our JavaScript infrastructure and JavaScript templating. And we wanted to make sure we didn't mess anything up. There's this huge grid of all these different features. And that's when we first started using this. And then we thought, we should just use this for our entire UI. And so now we do. We use it for every single part of our product. We have over 500 end-to-end perceptual diff tests on every single release. 8 minutes after you submit a change, we go and kick off those tests. And so we went from this standard kind of continuous deployment setup to this one. So it's the same thing again, except once it hits revision control, we just deploy it. We don't even run the tests. We just go and deploy it to a staging server. We run the automated tests at the same time as the perceptual diff tests. And then the release pusher looks at both. And they say, OK, what are the regressions I had in my perceptual diff? What are the ones that, what are the tests that failed? Is that acceptable risk or not? Do we need to cut another release? I make the decision as a pusher, and then we set it live. So let me give you some examples of the types of things that this can catch to really underscore what you can do with it. OK, so these are before and after pictures, and then the diff in the bottom. That's usually how this is. We added a button, the building button. That's you can see that one. That's pretty easy to see. But every time you launch a feature, you see it. The Pdiff picks it up. Every little UI change, every functional change in your state, you can see it. Here's one where the Giants won the World Series, and we're being silly. So this is totally expected change. Again, all the colors changed the way that we thought they should. So the release pusher is going through all the diffs, and they're like, oh, look, yes, those bars changed because this change changed the bars to that color. That was expected. OK, this diff looks OK. Here's another one. We totally redid our checkout page. And on the left is the old way, on the right's the new way. And you can see this huge diff, tons of things changed. And at this point, the person who's actually pushing the version live would say, OK, I need to be careful here and make sure that all the different pieces that have changed correctly. This is a big diff. Here's another one. We changed a promotion on our homepage. So from the old way to the new way. And so now, here's one that's a little more harder to see. We're getting into the harder to see category. We went from 4 steps to 3. So on the top, there's a piece that's missing. So this one's kind of like the repeated the in a sentence. Have you ever seen that silly thing that's like a triangle with the word the repeated twice in it? Once you see it, it's really obvious. But until you see it, this one is actually kind of hard to see. Map change, that's pretty obvious. Here's another one where we added a column. This is, again, like having 2 thes in a row. When you first look at it, they look the same because the majority of the diff is very similar. So if you're trying to do QA on this, it's very hard. But this is where it gets killer, is the subtle example. So these are all features that you'd expected diffs. These are ones you would have to do this correctly. But where it gets crazy is in the subtle cases. OK, so here on the top and the bottom, all the content's the same. All the text is the same. What changed was the margin top on the div. So it moved, right? And it moved in a way that's actually conflicting with something else that might show up there, like an error message. And we found that, right? And it's no QA metrics in history ever had the margin top changed, test, right? So that's really cool, very subtle, and you don't regress in that way. Here's another one where the size of the bars changed horizontally. We changed the padding of it. I still can't see this diff. I have the diff on the left. I have the before and after, top and bottom. And if I stare at it, I still cannot see the difference between the two. But there actually is. I swear to you, there actually is a difference. Here's one where we had a table of data. And as humans, we look at just a pile of numbers, and we're like, that's a pile of numbers, and then we stop looking at them. And here we lost some of the numbers in a pile of numbers, and no one noticed, And it was this big regression, because this is a bias table. It's very important to the statistical properties of the product that we sell. And so Pdiff picked that up. And that's a regression deep down in Python land. Some data that was being generated was missing. So we picked that one up. And here's one I really like a lot. There's a single pixel line that changed in the way the graph is rendered. 1 pixel. And it moved the page all this way. And nobody saw this. Even the person who wrote the change didn't see it when they were writing the change. But this picked it up. It pushed the page down, and you could actually see the effect. So once you get enough of these subtle differences, you start to have a lot of confidence that any problems you're going to have are going to be picked up by this thing. Like any little change, there are false positives, and we can talk about that later, but it's totally worth it. You have so much confidence that you're going to pick up every little difference that you feel a lot safer when you're doing a continuous deployment. And here's another one. The sort order changed from lexical to numerical. Oops, we've all done that. We picked it up. We knew it happened, and we didn't push that. And so now we're doing this for everything, and I really mean as much as possible. So web view and a mobile app, we're trying to do that. Here, this is the HTML. We send it in email. We actually rendered that and diff that. So every time we change the way we send an email to people, we know that we've changed it and how. And we have a matrix of 30 different states the email could be in, and we test them all. So we're trying to use this for everything so that our continuous deployment and every part of our product that touches our customer is like verified, And every time we find a regression, we try to add a Pdiff test for that state, that case, just like you'd add a unit test in code. So really, in a nutshell, like perceptual diffs are the ultimate end-to-end test for web-based software. That's kind of what I'm getting across here. You can write integration tests and unit tests. You can have QA. You still need those things for really like rigorous testing. But you can also have perceptual diffs as a first layer to ensure, especially for continuous deployment, that your deploys are not going to break the world. So there's a bunch of tools out there for doing this or being involved. For doing this and all kinds of infrastructure around continuous, screenshotting pages, diffing them against previous versions. We all know about some of the integration tools that are out there now, like Jenkins and Travis CI and Circle CI. There's a lot of continuous deployment tools out there also for hooking this up. What has been missing, in my opinion, is the tool to actually do the perceptual diffs. There are some really good tools for doing hosted Selenium tests, like Sauce Labs has some really great stuff for hosted Selenium tests. And Selenium can do a lot of the things that I've been describing along the way. But I think that in general, there's no end-to-end solution. We're talking about continuous deployment as this great thing, but it's not safe unless you throw a lot of resources at it. And I think what we found here with perceptual diffs is a way to do continuous deployment that has a minimal amount of human involvement and as much testing as you can hope for. So anyway, the lack of a perceptual diff tool led me to build this. So today I want to tell everyone about Depicted, DPXDT. This is a tool I built. It's open source. It's Apache 2.0 licensed. It's on GitHub under DPXDT. And this is a API server and kind of toolkit for integrating perceptual diffs into your continuous deployment or your continuous integration system. It's not a religion here. I'm not trying to make you adopt my Spring framework flow with my Maven repositories. Like, I don't care at all what your software is built in. As long as it's on the web, you should be able to use this and integrate with this API. So I was going to demo this for you to show kind of what it is and what it can do so you can understand how this would fit in to your release process. Let's see if I got this. Okay, so the first thing is, all right, so this is the project on GitHub. I finally wrote a README. So this goes into all the details, the API server and everything else. This is the website. You can go in here and create builds and manage your builds. And basically, the reason it's built this way is I've got a year plus of experience now doing things with perceptual diffs and understanding the cases that you need to deal with. So for instance, archaeology, as we call it. This broke. When did it break? Okay, let's bisect history. Let's take the current change. Let's take a month ago when we knew it was working. Let's pick the middle point. Is it still working or not? We do this with changes in source code repository all the time to find a bug in an algorithm, right? Well, now I can do that visually. I took a screenshot of the product a month ago, and I took a screenshot today, and those both are fine. So now let's go 15 days back. Let's look at a screenshot from that day. Is the button there or not? Did the text change or not? Okay, it didn't. And now I can go through that process of doing archaeology to find the exact change where the visual diff of the product changed, So that's like the kind of things that we've needed on our project. And so this tool is trying to enable all of those types of use cases that you use for source control management, but actually for like product screenshots. So the quick demo I wanted to do is, I'm not going to bore you with all the details of the API. You should just check out the project for how it works and see what that does. But the idea is it's an engine for running perceptual diffs. So I have here a project, One Big Fluke 3. That's One Big Fluke's my blog. I have this tool I built called SiteDiff that will crawl your site, pull all the URLs out of it, and then run a perceptual diff test on them. So even if you're a web developer, you're not even an engineer or in operations of any kind, you could try to use a tool like this if you're just changing CSS. Let's see if this works. Oh, actually, no, that's not going to work because I need this version. Okay, so, all right, so this is site diff. So what it's doing is, oh man, my key doesn't have access. Let's see if this works. Can I set up a key? The curse of the demo. Oh, of course. Wait, let's see how deep I can get in here. No. All right, let's try that other one because maybe that did work. Sorry, I'm trying not to be too confusing. All right, okay, that did work. Sweet. Okay, so I have this release, and what it'll do is it has a list of URLs. These are like the URLs being the state that is screenshotted. And we'll go in here. So here's my blog. It's taken a screenshot. This is a screenshot generated by Phantom.js. It's a really cool tool. And it has a before and after of what's changed with the page. Okay. So the first thing you do is you establish a baseline, which is saying like this is my page before anything happened. And so that's what I'm trying to do here. So okay. So here now I have this is a screenshot from before, or at least I did earlier today. Here's a screenshot from now on the right. And then what'll happen is it'll actually run a diff. Now here's a great example of a false positive. The Google Plus comment widget fails to load sometimes. So one of the things this tool does is it lets you add CSS to the page to hide elements like that might change or be flaky. Or if you have a timestamp that always updates, you can like set it to 100% gray so you don't have it interfere with your diffs. So you only care about the things you care about, right? But anyway, so there's a whole workflow around what you need to do with perceptual diffs once you get there. And again, I won't bore you with the details, but one of them is like approving it. So, okay, yeah, that diff looks fine to me. I will approve that. You can zoom in here and look at just the diff and exactly what changed on it. You can show before and after images to actually see that. I wanted to do an example though here. I'm going to mark this. I'm going to mark this release as good. So this again, this workflowy thing. And then what I'm going to do is I'm going to go into my blog, and I'm going to edit the HTML here. And I'm gonna make it look different. So that's my crazy plan. Okay, so I have this one part which has like a bunch of boxes around logos. So here's like an article here that I'm screenshotting. I have this DPXDT logo here. I'm gonna add a box around it so we can. Sorry, I gotta do border 1px solid red. Let's make it fatter so we can all see it. And okay, so I save my template. Cool, and then I load this again. All right, so now it's this big red thing, right? Before, after. So that's in my browser. This one's I can see, right? So now I run the Pdiff tool again. It's going to go scan my page. It's going to go kick off a requested run. And then it's going to say, OK, you'll be able to see what's going on right here. So now if I go there, it says it's pending. It has the old diff. It found the good release from last time, right? This is kind of like the golden, right? This is the golden. And then there's a set of background workers that are chewing through this, running Phantom.js on just like a cloud VM somewhere, taking a screenshot. So here it can see this red outline. And then you can see it's already chugged through and generated this diff. So then here we go. So now we have this before image, we have an after image, and we have the diff, where it picked out just the thing that's changed, right? The rest of it's just white, because nothing else on the page has changed. So that's what this tool is all about. It's an open source way of making the screenshots, running the diffs, and then managing a release, tying your continuous integration into a set of perceptual diffs, similar to how you'd set up a set of unit tests or integration tests and then connect them to a release. That's the whole point of what I'm trying to do here. It runs behind the firewall. It can run with SQLite on your laptop. It can run on App Engine in part. Like I'm trying to make it so it can run everywhere because I just think it's just generally useful. It's totally changed the way that we build software and products for me and my team and my co-conspirator on the Google Surveys team. So I just really recommend you check this out and try to use it. Okay. So that's my demo. Again, best practices is you've got to do parallel screenshots. You kind of want some static state in production, so like a setup user state, like users who are like this, users who are like that. A lot of the time you want to fake out auth at the lowest level so you can have usernames or that are static. The CSS selector hiding thing I mentioned, blurring is another thing you should do that's similar to that. And then one of the coolest things is you can drive the UI with JS events. So we have parts of our system that have to click on 5 different things to open up all the different state that could happen, right? Well, you can do that. You could script it in Selenium too, right? But you can just inject JS into the page that runs the entire DOM, gets it to exactly the state that you want, and then diffs, and then takes a screenshot right then, and then diffs it against the other one. So you even get certain integration tests in UI changes. You get those for free out of Pdiffs. And there's lacking test coverage in our JavaScript that Pdiffs have been able to pick out, which is really cool. In the future, I want more declarative configuration, so less of an API and more of a config file. I want to have webhooks and the kind of deep integration for GitHub and other kind of tools. I really want this to work for Firefox and IE and a VM and all of the web-based, like all the mobile web clients that we can get our hands on. And the web page tests performance tool is so great. I would love to carry over some of that into Pdiff. So Pdiff could kind of have this double meaning. It's perceptual and performance. So you could see not only regression in terms of the way it looks, but in the way it loads. We should be able to do both of these at the same time. So it's open source, so please help me make that happen. Okay, so I want to have time for questions, so that's why I'm kind of going quick here. The conclusion is perceptual diffs are the best thing. They really are. I cannot stress it enough. You got to try it. If you have anyone in your team, I've carried the pager for a service. I've dealt with failover situations that are horrible. I understand how continuous deployment is scary as hell. I get it. Totally understand. I think this solves the problem. So if there's anyone on your team who is just totally opposed to doing continuous deployment, please, and you have web-based software, again, that's the requirement, right? Bring this to them and try it out and see if it'll turn some curmudgeons towards continuous deployment. Because I think continuous deployment actually results in fewer bugs in production for less time. But that's kind of a religious argument at this point. I don't want to change that. The last thing I was going to talk about was the effect on our team. So although I work at Google and our team is at Google, the way we're structured is very different. We're much more like a startup than most teams at Google. We have a group of people, a couple dozen people, that all sit together: sales, marketing, operations, engineering, user experience, product, everybody. So we feel like a startup. And one of the things that's cool about this continuous deployment in Pdiffs, because we've really closed the loop and enabled continuous deployment, it's reasonable for a salesperson to ask the engineering team for a feature the same day if it's important. And we can turn that around because we have confidence in the fact that we won't break the world when we push. So there's a sense of not only are you motivated to help everyone out on your team, but you get this general sense of respect for all of your teammates, regardless of their role on the larger team. And that's an effect I never anticipated would come out of this. I was looking for a technical solution to regressions, right? But it's enabled this amount of mutual respect that's been great. It also empowers junior engineers to do more. Oh, I'll never push. You hear that from junior engineers. I'll never do the release. But it's like, if you know you're not going to destroy the world, then you will. So for ramp up and empowerment, this has been a really great tool, letting everyone contribute, which has been great. And that leads to confidence, which lets people grow as developers and in general. So I think that's the other kind of big takeaway from all this. So again, the links depicted is at GitHub under bslacken. The testing at Google Scale talk is awesome if you're curious about how Google does all this crazy stuff. My day job, it's Google Consumer Surveys, G.co Consumer Surveys. And I want to have time for questions, so please come up to the mics. But thanks for coming today. So I think there's a mic there.
There's a mic up here if anybody has any questions.
If you're skeptical or anything, I would love to...
Walk over to the mic so we can hear your beautiful voice.
Do you have any rollback, or is it all roll forward?
So yeah, do we have any rollback, or is it all roll forward? We try as much as we can to roll forward on everything, but sometimes you have to roll back. We have the ability to roll back. Most of our app is actually built on App Engine, so the rollback is literally clicking a button. Other parts of our app are not on App Engine and aren't as easy, but yes, we try as much as we can to roll forward.
Hey, so how do you use this for sites that are really AJAX heavy and have a lot of dynamic content and stuff? Do you end up just having to do a lot of data mocking and stuff like that?
Yeah, so we have a bunch. So the question is, what do you do with a data heavy or dynamic data site? And what we do in that case is we try to put as much kind of static state on the server side as we can, or a static user configuration. So let's say we're talking about Twitter or something like that. We'd have a set of tweets stuck in time. And we'd set them up for that user, and then we would make it so that the user doesn't see any more changes going forward. So it would be a dynamic view, but the dynamic view would never change from that point on. And from time to time, we'll refresh it. Like if we go back and we're like, okay, we've added some features now, we'll go and reset the Pdiffs and actually start with the new dummy data. And so we're constantly adding kind of new dummy data for all the different new cases that we deal with. But if it's crazy dynamic, one of the things you can do is just, if you set the color of the text to blue and the background to blue, then you just get a blue box. And sometimes that's all you actually need. You just want to make sure the blue box is there and it's correctly positioned relative to other things, and that's good enough. So, for Google search results, for instance, that's what you'd have to do because every single time you hit the page, it's different, right? So you'd really care about the composition of the boxes. So, thanks.
I heard that you were automatically deploying to staging, but it sounded like you're using a human to deploy to production. Is that correct?
Yeah, so the question is, do we use a human to actually make the decision to deploy to production? Yes, and I thought that we could get around this. I thought that eventually if the Pdiffs all pass, we would just set it to live. That is my next goal. The false positive rate is still a little too high. I would say it's 1 in 100, or if we do 30 Pdiffs a day, we get 30 Pdiffs of 500 tests, so let's say it's like 2,000 tests a day. Somewhere between around 10 of those are going to be false positives right now. So that's too high of a rate for that.
So would you have the capability of being able to say, well, this developer, he got drunk last night, and so we're going to put him on hold. We're going to make him human. The other guys, they have good records, so we're going to let them continually deploy.
Yeah, I mean, all software is a social problem. So I don't know about that one, but I think we try to have goodwill and hope that people do the right thing. And we have the one-click rollback. So in the worst case, if he's like 2 a.m. and he's rolling forward, we at least have a log of that and we can roll it back. But anyway, we would like to take humans out of the decision for continuous deployment once we have enough coverage so that if all the Pdiffs pass, then it's live, and that's that.
Thank you.
Thanks.
How much of the rest of the Google infrastructure do you pull in during these continuous deployments? Is your code self-contained that you own every line, or is it kind of continuously integrated with the rest of Google, like a lot of?
Yeah, you should check out that testing at Google scale. It's the big build that Google does, and we use a lot of the common infrastructure for that. We're all built into the one Google repository that every team uses.
But when you are pushing out, is it your change that goes out, or could other people at Google's change?
Oh yeah, no, we pick up everything since last time. So someone in Zurich who landed a change like late at night will be in our build, and so it's continuous integration, one main branch, one line. There's no release branch. So you hear about people doing release branches. We do not have a release branch. Head is our release branch.
And then you branch it to release, or?
No, we like copy files from head to disk and then release. And there's a number for each change, like the SHA-1 or whatever. That's what we release on. That is our release. And if that release is no good, then we pick the next one off the head, and then that's what we use. So we never branch. We're just picking the moment in time. So it's kind of crazy because there's no cherry picking, right? You just have to cut from head again. In the worst possible cases, what we've done is we'll synchronize to that SHA-1 locally, manually patch the files on my own machine or something like that, and then push to production like from our own machine. But I've done release branches in the past. Cherry picks become, as we all know, really hard to manage over time, especially if you have like 500 of them for one release. And so we just got over that. We just don't do that. We always ship from head.
And then how common is what you guys do with the rest of what Google is able to do?
I don't know another team at Google that does this. I do know that products like Google Plus are shipping much more often than Google has in the past. The Google Web Server also is pushing a lot more often than it used to. So that's great. So there's a culture in Google to make this faster. But the risk-reward trade-off, because we're like this startup-y group, we can make a higher risk trade-off. If Google search goes down, there's like a huge problem, right? So that's, again, part of this. But I think, this is something I'd like to enable all teams to do. Cool, thanks.